All right, so again, I've given you these three problems. We're going to go over all three right now. And I was more concerned that you understood the logic than I was that you make it pretty colors, etc. Again, with that stuff, that should be the least of your worries. I've had people tell me before, the only day in this class that goes fast is when we have a hands-on test. I get that. All right. And, again, I don't think you'll have any problems with the test that you'll take Thursday. I really don't. But try the best you can to apportion your time correctly. All right. Like I said, with those four problems on the test on Thursday, each is worth 25 points. You can see the breakup because they'll always be on there. All right. We always show the apportionment of points. All right. So again, on this one, when you come in here, what I wanted to show everybody, and I mentioned this already before I had a tape problem here, is right at the top. First of all, you'll notice I'm not using any of these. So I really don't need them. So if I want to, I can just get rid of them. It doesn't hurt to leave them there. It doesn't hurt to get rid of them. All right. In fact, if for some reason there was a part of my program that needed one of these, and now I removed it, I would get an error message on that part, and it would allow me to go in and actually add those. We'll look at that at another time. But right underneath this thing in here, you'll notice that the name of this is Form Calculator. And then right below this, we've got something that says Public Form Calculator. I don't expect any of you to know what this means. But when we get to Chapter 12 and we talk about classes and object-oriented programming, you learn about what's called a constructor. This is the constructor for that form. You don't have to worry about it right now. All right? But these variables, these are the variables I want to use throughout the program. The first number, and that's going to represent what's in that first text box, the text box that says for number one, number two, which is the other one, and result, which is the result. You'll notice that I made the result a double, and it didn't work the way I wanted it to, but we'll look at that in just a minute. And that's because, for example, if I divide 37 by 14, there's a decimal remainder. It doesn't go in evenly. All right, but I'll go in and change it so it works the way I want it to work in just a second. Now, a question got asked to me, what happens if somebody leaves nothing and it puts nothing at all in there? And if you look right here, the first check that I'm making is I'm saying if either number one is blank or if number two is blank. So if either this is left blank or this is left blank, if either one is, or they both could be, it doesn't matter. I bring up a message box that says you must input a value here, telling you had blank input, giving you just an OK button, all right, and putting it up as an error. So in other words, I'm going to run this. Whoop, wrong one. I got to go back and change it so that my setup project is back at this one. So that's calculator GUI, set a startup project. Okay, now when I run this, if I leave it blank, I want to put this up here so you can see all of it. All right, and I tell it right here to add. You must input a value here. Now look what that is. That's this. You must input a value here. That's the text. Blank input, that's the title. OK button, that's the button. And error, that's the icon. All right, so this is one way of handling, having no input. Is it the only way? No. Is it the best way? No. But for what we've learned so far, I think it's something you can handle. All right, maybe I'm right, maybe I'm wrong. Did I expect you to do this? No, you weren't asked to do that. If you did it, great. And if you didn't, also just fine. What you are given when you take a test or when you do a lab or when you do a homework in here, literally what you're given are a set of minimum requirements. And that should make sense to you. If you want to go over and above that, that's your call. Now, whether this is fair or not, I don't know, but the way that I grade is if you go over and above that, you do something wrong, I take off. So if you say, well, that isn't fair, then just do the minimum. That's totally fine. I would strongly suggest that if you're doing this, that, let's say it's you take the test and you've got all of the problems done, but the last one you're like, this isn't, I will tell you, the hardest problem on there is a console. and you go, I'd like to make that a GUI too, just to see if I can do it, then do that. But when you get the console to work, save that. If you're going to make changes to a program, save it, and maybe even make a copy of it or something just in case you screw it up. I've done that in the past. I'm going to make this better. No, all I do is screw it up. All right. Now, what I want you to understand, though, is if you notice in here, this add routine that's right there, the first thing I'm doing again is checking. And if there's nothing in there, in either one of those, I give the message box and I return. Return means just get out of this routine. Don't run this routine anymore. All right. I don't expect this to make a lot of sense right now, but the word void here means that there's nothing to return. You are void of a return is exactly what it means. If I get down to here, I've got something in those text boxes. All right. But it may not be alphabetic, just so you know. It may not be, or I'm sorry, it may not be numeric. So how do we do that? That's something we learn in a later chapter. I don't want to go through that now because I don't want to confuse people. All right. So let's suppose I put 12 and 13 in there. So then 12 will become number 1, 13 will become number 2. Result will be 12 plus 13, which is 25, and then I'll give the result. And notice I just say F0, which says no decimal places. All right. But now notice I'm doing the exact same thing here, right there, when I do my subtract, and I'm doing the exact same thing here when I do my multiply, and I'm doing the exact same thing here when I do the divide. So a natural question might be, isn't there a better way of doing that? And the answer is yes. You write a routine that just does that stuff, and you're in one routine, and you call another routine. We're going to learn that, but we haven't gone over that yet. And again, since I don't want to confuse people, I did it like this. But so for all 4 of these, what am I doing? I'm coming in here every single time. Let's just look at the add. All right. And it doesn't matter. We could pick out any of these, but I'm checking for no input in one field or the other. All right. If we get that, we're giving the message box and we're getting out. If we get down here, we got input. We don't know what it is yet. There's a thing that we'll cover in a later chapter that's called try parse. And we will, instead of doing this convert, all right, I mean, if I run this right now and I put hello, goodbye, and I try to add hello plus goodbye, what happens? Well, not good things. Because I'm trying to take a string and use its numeric value, and it doesn't have any. And the same thing, you know, with number 1 and with number 2. So it's going to break. All right, so how do you get around that? You use something that's called try parse. What does that mean? It's in a later chapter. I guarantee you we will go over it. It's actually in the next section that we'll be covering. It's somewhere in between chapters 5 and 10. I don't know which one. All right, but we will cover it in a lot of depth. All right, so this program is far from perfect. But if there are numbers in there, we'll add them up and we'll put them in the last text box. Does what's going on there make sense to everyone? Questions on that? Is this the only way of doing it? Of course not. It's the way that I did it. All right. And I just want you to see this. If I did grab this code that's right here, if I grab this code that you see that's right there, and I copied it to the clipboard, I just want to show it to you. I'm going to take that code, I'm copied it to the clipboard. I'm going to go down to the bottom of my program, and down at the bottom here, I'm going to type private void. I'll give it some name. And I'm going to say check for blank, input. That's maybe not a great name, but it's what I'm doing here. And I paste that in. Now I've got this in its own routine. Does that make sense to everybody? So what I can do if I want to is I can come in and I can take all this code from my, I've been using the plus one. So I can take all this code from my add button. Now I can take all that and I can comment that code out and I can replace it with a call to check for blank input. And I can call that from here, and I can call it from here, and I can call it from here, and I can call it from here. So rather than writing the same code, which doesn't have that many lines, maybe 10 lines, but 4 times, I write it once. And I call it 4 times. And just to show you that that will still work, again, it's now commented out of my ad, but it's there. You know, the call is in there. So if I run this, it should still, if I put no input in, it still says you must input a value here. So that works. So that's what we will be building toward. And one of the reasons that I've used that simple example that we went over from day 1 and 2 on the payroll is it's something most people can identify with. So next week, when we go into chapters 4 and 5 and beyond, or the end of this week, whenever it happens to be, I'm going to go back to that payroll program and I'm going to keep adding to it, all right, as we go on. All right. It says here, input string was not in the right format. I'm not sure what's going on there, but, oh, I know what the problem is. I'm calling this routine now, right? But now I've got the return statement here. So when it hits that return, it's returning, but it returns and it's trying to go on and do that anyway. So I'd have to make a couple little adjustments, but it wouldn't be much to do. That's what I'm trying to get across to you. All right. If you understand how this program right here works, really, you should have no problem, I don't think, with the test. Now, maybe I'm wrong. I don't know. Are the ones on the test just like this? Of course not. All right. But I've already told you what a couple of them are very similar to, and they're not hard. I think you could do those right now fairly quickly. So again, you'll notice that when you look in here, like I said, I try to come up with good names, number 1, number 2, result, my names of my buttons. Okay. Now, one thing that we will do, not today, but I just want to show you this, is right now, we are doing all of the code right in our button click. Does that make sense to you? We're saying when you click the button, run this code. Guess what? We're eventually not going to do all the code in there. You might say, well, why not? Well, what if I want to come in here just to show you what we'll be moving toward fairly quickly? But if I come in here and I go to my design, well, if I look at my toolbox and I go down far enough, there's something in here that's called a menu strip. And I put it in there, boom, now I got a menu. So if I decide, for example, that I want to put in 4 options here, I want to put in add, and then maybe right next to that, I want to put in subtract. And right next to that, I want to put in multiply. And right next to that, I want to put in divide. Now, that hopefully you agree, that literally took seconds. Now, I'd have to put in code there to make it work, but menus, just like buttons, respond to menu clicks. Sometimes what happens is you build the interface and somebody else says, this is too clunky, get rid of those buttons. If you've got all the code in the buttons, now you've just lost your code. But if instead of putting the code in the buttons, you put the code in its own routine, like I just showed you with that example, now you can call that routine from either the buttons or from the menu options. That's one reason that you write routines like that, so they can be called multiple times from multiple places. And you're going to see all that as we go on. All right, just so you know, too, if we didn't like this, we could have had add here, and then we could have come in and literally come in and put the subtract and the multiply and the divide right underneath it. You can do it that way, too. All right, so you can literally build your own menu system, and it can be as complex as you want. Those of you who were in the class last semester, maybe you remember a little bit when we built like a 2-tiered menu system using CSS or using HTML. It's a pain in the butt. Here it's clicking a few buttons. So it's a lot nicer to do it that way. All right. Any questions at all? Anything on this particular problem? Anything? I mean, it's your time to ask if you got a question. All right. Then I'm going to bring up the next one, which was the calculator console. So I'll bring that one up. And before I do, I'm going to reset my start project to right there. Oh, one thing I said I was going to say to you before, and I want to make sure you hear this. I'm going to go back for just a second to the GUI. All right. And when I did the GUI here, when I did the divide, it's kind of an important point. That's why I want to bring it up to you. You may or may not have noticed this. If I put in 37 and 14, okay, 37 and 14. 37 divided by 14 is 2 with a remainder of like 9 or something like that, right? Well, if I do that now and I run this one, let me go back to this one again. I think I'm setting the right one. Yep. And I put in 37 and I put in 14 and I click divide, I get 2.00. That isn't what I want. I want 2 and 9/14 or whatever the heck, which is like about 0.63. Why am I not getting that? Well, the reason that I'm not getting that is I'm dividing a whole number by a whole number. Even though I'm putting it into a double, even though I'm doing that, it still doesn't work. Now, what I think you can do here, because this is what you do in other languages, is I can say, hey, treat this like it's a double. So instead of making it 37, make it 37.0. All right? Because if you do a double divided by an int, it gives you a double result. But an int divided by an int, it's like if I said divide 6 by 4. If you do that, the result is 1. It's not 1.1.5, it's 1. But if you divide 6.0 by 4, or 6 by 4.0, or 6.0 by 4.0, you get 1.5. Now let's see by just making that change if that fixed it. I don't know if it does or not. It should. But now if I come in here and I say 37 and I say 14 and I click divide, now I get 2.64. That's what I wanted. I didn't do that originally. It was just an oversight on my part. I didn't notice that I didn't do it. This is called casting. And you'll notice the cast always has to appear on the right-hand side of the equal sign. You're making a copy of what's in number 1, and you're casting that. If I tried to cast over here, I'd get an error message. You cannot do that. You can only cast with what you're assigning to. You can't cast that value. I don't know if what I'm saying makes sense or doesn't make sense. All right. So I'm going to save that because I should have done that. And again, I can do this one, or I can do this one, or I can do them both. It doesn't matter. So if I do them both like this, all right, and I save and I run it again, I should get the same 2.64. And I do. And I'm not going to show it to you. But again, I could just remove this one and just do this one, and it would still work. All right. And that's used a lot in a lot of different languages, when you have to make sure, that you're working with apples and apples as opposed to apples and oranges type of an idea. So that was the GUI one. Let me go back again to the console. I want to set that as my startup. All right. Now, there are some books that what they do, this is not one of them, the one we're using, but there are some books that probably teach you the equivalent of the first 4 or 5 weeks of class before they even tell you what a GUI is. They do everything with console. And maybe that's a good idea, because when you use a console like this, what it does is it forces you to think about the logic. When you start doing GUIs, you start to think about appearance. Really, the appearance is not that important. All right, and you can come up and make a really glitzy looking program. I've seen these before. Somebody's got a beautiful interface, but the program doesn't work. And I've said before, give me a butt ugly interface that works as opposed to a beautiful one where the program doesn't work. So when you are working on a test, assignments, whether it's a lab or a homework, that's your choice how pretty you want to make it. But if you decide when you are doing your tests that you want it to look very generic, so if it's a GUI, you want it to be that kind of dull gray background, and you don't want to do anything with a font, that's totally fine. Make it work first, then worry about that kind of stuff. All right, so in here, since I'm printing them all out right away, I made separate variables for each one of these. Sum, diff, prod, and quote. I could have called them sum, difference. I could have called them add, subtract. It doesn't matter. I could have called them any of those. All right. So it says, please enter the first one. And notice I have to convert here. And again, this program will blow up if I put something non-numeric in there. That should make sense to you. Also, since it's an int, this program will blow up if I put a decimal place in there, because an int expects it to be only and solely a whole number. This program will work with negative numbers because we didn't say it couldn't. All right. We could make it work with just positive numbers by checking. And I mean, as an example, I could check, and if the number you entered was less than 0, I could run what's called the absolute value function on it, which takes away the negative side. All right. But I've got these things, so I'm going to input number 1 and input number 2. That's what I'm doing here and here. All right. Then I just add them for the sum, subtract for the difference, multiply for the product, and here I did cast. That's why that one worked right at the start. All right. And then I just wrote it all out. Now this right line that's in here, couple things. First of all, it could have been put into one string. We could have done that. That would have worked just fine. Or we could have built a string outside of it, and I showed you this in an earlier program, and then just do a right line of that big string that we made. All right. Typically, in this language, if you don't take a number value, if you do not convert it to string like I've done, it still works. And it works correctly. But again, I want apples with apples. So I'm taking the number, and since I'm printing it in the confines of a string, I'm converting it to a string. All right. And I do that for the sum, the difference, the product. And you'll notice just for the quote, because again, that's a division, I'm putting that one to 2 decimal places. So I'm going to run it again right now, and I'm going to put in there 37 and 14, and it should say what? 37 plus 14 equal 51. 37 minus 14 equal 23. 37 times 14, it's about 518. And 37 divided by 14, it should still give us the 2.64, I think it was. All right, so I'm going to run that. Enter number 1, 37. Enter number 2, 14. And it does 51, 23, 518, and 2.64. This is probably harder than the problem that you're going to get on your test. All right. Let me ask you this. Okay, there's what? 1, 2, 3, 4. There's 7 of you in here. Okay, I'm asking you this question. Let's say I wanted to find out, so you take your first test, and we'll put Jameer in here also. So there's 8 of you. So the test, let's just say, is worth 100 points. All right. I want to find out the average test score. Somebody in here, anybody. Tell me, how would I do that? Anybody? Yeah. I'd add up the 8 test scores and I divide by 8. That makes sense. So let's say that, you know, we had 100, a 95, 195, 195, and 195. It's probably going to give us an average of somewhere around a 97.5. So that'd be 195, you know, which is 100 plus 95 times 4, like 780. I divide that by 8. That's how I do it. All right. If you can do that, I think that's probably easier math than what we just did here, or pretty much the same math. All right. Any questions on this problem? Anything I did, why I did it? Yes?
When would you want to use an int instead of double?
When do you want to use an int instead of a double? Well, in here, these are both whole numbers, correct? So a whole number plus a whole number will always be a whole number. So that's why I made sum an int. A whole number minus a whole number will always be a whole number. That's why I made diff an int. A whole number times a whole number will always be a whole number. So I made prod an int. However, when I do I could have left quote as an int, but then I would have had the same problem you saw before. It would have said 37 divided by 14 equals 2. So that was a long answer, but the short answer is if you want to preserve the decimal place. Okay? One of the problems I thought of giving you here, and maybe I'll even give it to you next time, and you guys might have had this, I don't remember, in the JavaScript class, that you give somebody, you say, okay, you've got change in your pocket. It's anywhere from a penny to 99 cents. You with me? All right. And what I want you to do is I want you to show me the biggest configuration that you could make of quarters, dimes, nickels, and pennies. All right. Now, believe it or not, when you do that, that's all ints. But what you use in there is what's called the remainder operator or the modulo operator. Now, I didn't put that in here, but I just want to show you that really quickly, just so you see it. I'm going to put in here int mod equals 0, just like that. All right. Then down here, I'm going to put mod equals number 1, and then a percent sign, number 2. That says give me the remainder. So what I should get when I run this, I'm going to add another write line in there, is it should say 37 mod 14 equal 9. All right. So even with that, it depends on what you're doing. If you're working with something, for example, payroll, you'd probably want to take hours, because I can work part of an hour. I don't want to work, 3/4 of an hour and have you hack that part off. I want to get paid for that, right? And when you talk about rate, those would probably both be doubles. All right. If you talk about number of employees, that's not going to be a double. Whether you're full-time or part-time, you're still an employee. So that would be an int. All right. Sometimes what it comes into is, when do you use a double versus a float? Because the only difference is how precise it is, how many decimal places. And double actually goes out further than float. But with float, you got to put that darn F in there, and that seems to confuse people. So most people use ints all the time, and they use doubles. What's even more confusing on that, though, is when you use an int and you convert it, it's actually what's called an int 32. It means it's a 32 byte int, all right, or bit, I don't know, I think it's byte, but it's got a range from negative 2,147,000,000 something to positive 2,147,000,000 something. That's going to work for everything we do. It wouldn't work, though, for example, no kidding, all kidding aside, for something like the national debt. So when you use that, there's a thing called like a long int, which is even bigger, or we could use that. All right. And if we were doing, let's say we were working for NASA, and we were trying to get coordinates, and we're doing a moonshot or a shot to Saturn or something, you'd want to use doubles. You might want to be out to 20 or 30 decimal places, because that might be the difference between putting a satellite on there and missing something. All right, type of an idea. I don't know if I'm answering your question, but more than anything else, it depends. So I've now got this mod thing in here. It's gray because I'm not using it anywhere. So I'm going to just grab this at the end here. I'm going to copy that, come down here, hit enter once. I'm going to paste this in, but now I'm going to put in the mod symbol, which is a percent sign. All right. And instead of quote to string, I'm just going to say mod dot to string, and it doesn't need anything because it's going to be a whole number. All right. So if I run this, and I put in again 37, and I put in 14, now it says 37 mod or percent sign 14 equal 9. Those are the major operators that we're going to use. All right. There are other things that you can use. For instance, if you want to raise something to a power, we're not going to do this in here, but if we made our own calculator and you wanted to give, the calculator so we wanted to basically, if I told you, I'm not, but if I told you, hey, I want you to build that. All right. Really, I think at least by the end of this semester, you could build that without that much trouble. All right. Yours might not look exactly like this, but everything that you see here, at least these, are going to be buttons. These are also going to probably end up being buttons. These are probably going to be buttons. These may or may not be buttons. This would be like a text area. And this, if you give the user the chance to go one way or the other, that'd be a lot of work. But if you want a scientific, that'd be a lot more work. But you could do that if you wanted to. Keep it standard. Okay. All right. So last call. Any questions on this one? Any other questions? All right, then I'm going to go to the last one. And with that one, that was the temperature console. So I'm going to make that my start project. All right, and I'm going to close this one. And that was a console. And literally, I was looking last night for things to do as far as, to put on this test. And I thought, well, calculator is something, again, everybody can identify with. And I wanted one more problem. So I went out to the internet and I asked, I literally keyed in there into Google, beginning C# practice exercises. And this is one of the ones that came up. I didn't do it like they did, but I did use their comments. All right. So what do we have in here? We've got 3 variables. And this time I decided to make all 3 of the variables doubles. So if you wanted to put pi in there as the temperature for some reason, you wanted to put, if they said, what's the temperature or whatever, and you wanted to put here, maybe I should have said, instead of please enter a number, probably should have said, please enter a temperature. All right. Now I'm asking you to enter one between 1 and 100, but I'm not validating that. So if you put 1,000 in there, it's still going to work. You know as well as I do, if it's 1,000 degrees, we're not going to be here because we're going to be burned to a crisp. All right. So 1 to 100 made sense to me. I could have put more code in there. I just didn't. All right. And again, you'll notice then here is a convert to double. When we did these before on the, I'm not going to bring it back up, but when we did the int or the calculator console, since we were reading in number 1 and number 2, and they were both ints, those were convert dot to int 32. All right. Again, this program, just like the other ones you've seen, will blow up if I leave it blank when it asks me for a temperature, or if I put in something non-numeric. All right. I'm going to get the same kind of error I got before, whether it's a console app or whether it's a GUI app. That doesn't matter one way or the other. All right. So let's see. So here's the Fahrenheit. I take whatever temperature I inputted, subtract it by 32, and then multiply by 0.5556. Notice here, note right there, the parentheses. I want to put those in there, just like you probably learned in, I think it was junior high school. If I leave the parentheses out, it's going to take 32 and multiply it by this first because it does multiplication before it does subtraction. By putting in the parens, I'm forcing the subtraction to take place first. All right. And in this one, I wouldn't have needed them. I just put it in there because it helps me. All right. But it's going to automatically do that particular calculation first and then add the 32 to it at the end. That's just the way it works. All right. And then I print out what the results are. So this was a very short program. All right. But you'll see that if I run this, and I think with one of them they asked you to put in 50, and it says 50 degrees Celsius is 122 degrees Fahrenheit. 50 degrees Fahrenheit is 10 degrees Celsius. Well, up here it said 50 degrees Fahrenheit is 10 degrees Celsius. So that appears to work. All right. If I run it again, and now we're putting in 30, so if I come in here and I put in 30, the first one says 30 degrees Celsius is 86 degrees, Fahrenheit. All right. Well, I think that's what we set up here too. 30 degrees Celsius is equal to 86 degrees Fahrenheit. You actually can, I'm not going to show it to you right now because I don't remember how to do it. But if you have this program, let's just say you did on a test. You won't, but let's say you did. All right. And you wanted to put the degree symbol in there, you can actually do that. You can print that character. Now, I'd have to go Google how to print the degrees character in C#. And I just add it to my print line statement. So it's not hard to do. All right. It's something that's in that Unicode character set that you'd be able to add that. All right. So it depends on how particular you want to be. All right. But when you look in here, there's not much to this. I input the number, I do the one calculation, I do the other calculation, and I print out the results. This wasn't meant, and again, I'm not trying to talk down to anyone in here, but this test was not meant to be rocket science. All right. I tried to put problems in there that I figured you'd be able to understand and you'd be able to do. Now, if you were able to do all three of these, and I don't know if you were or not, but if you were able to do all three of these in the amount of time you were allocated, my guess is you'll have no problem on Thursday, you know, getting those done in 4 hours. Now, again, I've seen Evan's test, unless he's changed it from last semester, and I think I told you this, he gives them an hour and 50 minutes. All right. I hate putting time constraints on you like that. Sometimes, and I've had this happen too. I will tell you real quickly that I still remember that when I was going on for my graduate degree, I was taking an advanced operating systems class. There were 2 questions on it. And I read the first one and I was totally confused. You know, it was closed book, closed notes. I knew it. But I said, I'm not going to go on to the other one until I do this one. And I ended up failing the test. Why? Because I spent so darn much time on that first one, and I finally got it pretty much to work, which is what he wanted, but I was almost out of time for the second one. And it was a 4-hour class. All right, but I probably spent over 3 hours on the first question before I got it to work. You don't want to do that. Again, when you take tests, you will see, it will show you how everything is broken down. We are told to do that on our tests. All right, that way there should be no confusion for any of you. When you get the test on Thursday, you will get a hard copy. All right, you will do the work on your machines, okay, and we'll have to try to come up with something, if nothing else, just to be sure. You guys should be okay with Git. If you have to, you'd be able to push it to Git. You guys may have some problems with it, so please bring those flash drives, because if nothing else, you'll give me your flash drive. You'll save it to the flash drive, and your folder when you get done. Don't save it to the flash drive originally. Just save it to your desktop or whatever, then drag it over and copy it to your flash drive. All right. We may spend a little bit of time tomorrow going over some more of that. Like I said, I'm still working on this. All right. If you do have your flash drive with you and you want to bring it up here now, I will copy this stuff over so you've got that. You put it where you normally would put things. All right. If you did not bring your flash drive today and you have it at home, all right, and how many of you don't have the flash drive with you right now? All right, just you. All right, maybe I'll just grab you. I probably have another one. I'll just grab one. But the rest of you, if you want to just walk up here and give those to me, I can give you this stuff right now. All right, it'll probably take, even to do all 7 of you, it'll probably take about 5 minutes total. So it's not going to take much time. That is all I had. Again, hopefully there were no other questions.